As we move into chapter 20, there's a special topic called vectors. So, from us, most of the math we've done, quantities such as volume, length, mass, temperature, these are characterized by what's called a magnitude, which we also will describe them as what we call scalars. So, scalars really just involve like one concept. So, volume is just cubic centimeters, so it's a considered a magnitude, or magnitude could be like size, length, mass, temperature. So things like this we call scalars. Now, a quantity that is described by magnitude and direction is a vector. So if we add this extra element of direction, this now becomes what's called a vector. So a vector has two things, a size called magnitude or a length called magnitude, and then it's given a direction. So our first question says, find the magnitude of a vector in standard position with an endpoint of 24, -7. So to draw a vector, we can use what's called the x-axis and y-axis. So the ordered pair was 24, -7. So what we can do is actually plot this ordered pair. So I'm going to go ahead and make the x-axis go by sixes. So 6, 12, 18, 24. And then I'm going to make the y-axis go by twos. So -2, -4, -6, -7. So this is going to be the location of what we call the head of the vector. So the vector itself would start here at the origin, and then it would travel out here to this spot right here. So it kind of looks like an arrow. So the original position is usually called the tail, and its final destination is usually called the head. Now, the magnitude is the length of the vector. So the magnitude is the length of the vector. So if we call this vector v, if you will, notice how it has an endpoint of 24, -7. Now, what I can do, if I wanted to, is I could create a right triangle here. So this would be 24 by 7. So, but by the Pythagorean theorem, we know that c squared is equal to a squared plus b squared. So if I take the square root of c, c would equal then the square root of a squared plus b squared. So the hypotenuse is the same thing as, notice how the right angle is here. The hypotenuse is actually the same thing as the length of the vector. The length of the vector is also called its magnitude. So I could use the quadratic form, the Pythagorean theorem, to actually solve for the length of the vector. So notice how A and B are the lengths of the legs. So notice how one leg would be 24, so that'd be like 24 squared. And the other length would be 7. So it's going to be a 7 squared. So if I take the square root of that, let's use my calculator. So if I type in 24 squared plus 7 squared, that's going to give me the answer. And the answer would be actually just simply 25. So it looks like I don't have to round to the nearest thousand, since that just turned out to be 25. Now, another form we can use to find the length of the vector, what I can do is take the square root of the x coordinate squared plus the y coordinate squared. So if we let the order pair be x1, y1, we can modify this formula even quicker. So really all we have to do is, to find length of the vector, is go x1 squared plus y1 squared and take the square root of it. So notice that if I put this into the formula, the length of the vector is going to be 24 squared plus -7 squared. But notice how if you're using a calculator, You actually have to put the negative 7 squared in parentheses. Because remember, if you put negative 7 squared like this, the calculator will give you a negative 49. But if I put in parentheses negative 7 squared like that, it gives me a positive 49. So really, technically, the second one reads as a negative 7 squared. The first one actually reads as the opposite of 7 squared. So the opposite of 7 squared, what it's doing is it's only squaring the 7, which is 49, and then it's taking the opposite of 49, which is negative 49. So technically, on the calculator, this is not negative 7 squared. This is the opposite of 7 squared. If I want negative 7 squared, then you have to put the negative 7 in parentheses and square it on the outside, and it will do it correctly. So that's a little bit of formality on the calculator. So if I do the second square root, if you will, if I type in 24 squared plus then negative 7 squared, notice how it actually gives me the same answer. So really, I don't need the Pythagorean theorem necessarily, as I actually can modify this to being this formula here. So if I have the ordered pair for the vector, I can substitute that in to find the length of the vector. So in this case, we would have 25.